Good morning to all of you. So yesterday we finished Rolle's theorem as well as this MBT, that is mean value theorem. Some problems also we solved, and one of the problems will be asked in the examination. Today, in this continuity and differentiability, the last topic it is continuity. We should take continuous function. How to prove the functions are continuous? And one question will be asked in part D for 4 marks. They asked it for 4 marks, part D and part E and last day. This will be either it will be mingled with that matrices elements or linear programming. One 4 mark part A question will be asked, and 1 or 2 mark question will be asked either in part A or part B. And this is definite. Part 4 marks question in part E will be asked. Now you take continuous function. Suppose continuous functions. It is called continuous functions. Continuous functions we should take. Now what are continuous functions you should know first, and how to examine the continuity. In examination examine the continuity of the functions and it is called continuous functions. And for checking continuous function there are 3 conditions. 3 conditions should be satisfied, then we say that given function is continuous. Continuous function point of continuity. Yav point it is continuous anta irutte. Point of continuity will be there. Then point of discontinuity. When a function is not continuous at particular function point, it is called point of discontinuity. So examine the continuity of the functions anta kodtare. That is very important. It carries 4 marks question. Or if it is continuous function, find the value of k, find the value of a, find the value of b. Each are questions kodtare examination. Now first we should learn what is continuous function. Very important aspect and concept is what is continuous function. Take down the definition slowly and write. A function fx is said to be continuous. Is said to be a function fx is said to be continuous at x equal to c. At x equal to c, very important thing. A function fx is said to be continuous at x equal to c if it satisfies the following. If it satisfies the following conditions. Very important. 3 conditions are there. If it satisfies the following conditions, then the function is said to be continuous at x equal to c. I'll read again. A function fx is said to be continuous at x equal to c. That is a point. It is called point of continuity. We call it as point of continuity. See, some teachers, of course it is not there. They teach by graphical method. That is not there for you. Putting graph, line, geometrical interpretation is not there for you. Only it is algebraic interpretation for you. So I am not going to fill unnecessary things in your brain. We go by algebraic description and conditions. So I am not plotting a graph and to say where it is continuous, where it is discontinuous. We will restrict to this one only. And this is what they have asked in book also. And this is what is required for your solving problems also. Okay. A function fx is said to be continuous at x equal to c if it satisfies the following conditions. First condition, fx at x equal to c exists. Exists andru onde, defined andru onde. Eradu meaning onde. If that function is defined, say fx at x equal to c exists or defined. That means function is at x equal to, you will understand only when I solve the problem. You get it ella barkolli. Nan problem start madadaga you will understand the things. So fx at x equal to c exists or defined. Exists andru onde artha, defined andru onde. Second condition, limit extending to c of limits all last year you learnt. Limit extending to c of f of x exists. Yes, this is very important. First condition, f of x at x equal to c exists, define, and limit x equal to c f of exists or it is defined. X exists and defined under one thing. That means what? When you can say the limit extending to f of x exists under when left hand limit is equal to right hand limit. Some of the problem you have to prove left hand limit is equal to right hand limit, therefore this exists. Suppose left hand limit right hand limit kodade left hand limit right hand limit andre less than matte greater than anta bandirutte problem nalli. Problem ಮಾಡುವಾಗ I will explain. ಆವಾಗ you have to necessarily go for left hand limit and right hand limit. Here limit extending to c f of x is defined that when it exists anta bariತೀವಿ when limit extending to c minus fx, this is called left hand limit. ನೋಡಿ ಮೈನಸ್ ಬಂದ್ರೆ ಇಲ್ಲಿ ಲೆಸ್ ದ್ಯಾನ್ ಅಂತ ಬಂದಿದ್ರೆ ಇಟ್ ಈಸ್ ಮೈನಸ್ ಅಂತ ತಗೊಳ್ಬೇಕು. ದಿಸ್ ಯು ಶುಡ್ ಟೇಕ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ LHL ಇಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್. This is called left hand limit. When limit extending to c minus of fx LHL, then left hand limit is equal to ಯಾವಾಗ ಈ ಲಿಮಿಟ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ is equal to limit extending to c plus ಅಂದ್ರೆ right hand limit of fx, that is RHL, right hand limit. RHL ಅಂದ್ರೆ right hand limit. This is RHL. So limit extending to c minus f of x LHL, that is one particular thing that should be equal to right hand limit also. Limit extending to c plus fx, please plus andre right hand limit, minus andre and plus andaga greater than adu less than. C plus right hand limit exists. When this left hand limit is equal to right hand limit, then this limit exists. So second condition is very important. In some of the problems you have to prove LHL and RHL is same, therefore this limit extends. This is exists. Last condition, the third condition says, these conditions you have to mug up. The third condition says limit extending to c, the fx fx should be equal to f of x at x equal to c. This is the third condition. Andre ಇಲ್ಲಿ ಬಂದಿರೋ ವ್ಯಾಲ್ಯೂ ಇವೆರಡು ಸಮ ಇರಬೇಕು. In some of the problems less than greater than ಕೊಡದೇ ಇದ್ರೆ you have to calculate limit, you have to calculate this, see whether it is same thing. So third condition is limit extending to c of fx, that means whatever this you have calculated, that should be equal to first one f of x at x equal to c, then it is continuous. Once again I will read all the conditions. A function fx is said to be continuous at x equal to c if it satisfies the following conditions. First condition, f of x at x equal to c exists, defined. Exists andru onde, defined andru onde. F of x at x equal to c exists. Next one, limit extending to c of f of x exists but defined. That means limit exist ಆಗಬೇಕು. ಹೇಗೆ ಲಿಮಿಟ್ ಅಂದ್ರೆ when left hand limit, when can this exist is when left hand limit is equal to right hand limit. C minus of fx LHL and x c plus under right hand limit should be same, then this limit ಅವೆರಡು ಸೇಮ್ ಆದರೆ ಅದರ ವ್ಯಾಲ್ಯೂನೇ ಇದು ಲಿಮಿಟ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ಮೂರನೇ ಕಂಡೀಷನ್ ಈ ಲಿಮಿಟ್ ವ್ಯಾಲ್ಯೂ ಪ್ಲಸ್ ಈ ಕಂಡೀಷನ್ ವ್ಯಾಲ್ಯೂ ಫಸ್ಟ್ ಕಂಡೀಷನ್ ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಇರಬೇಕು. That is third condition is limit extending to c of f of x, what value you get should be equal to f of x at x equal to c, defined ಇದೆಯಲ್ಲ ಆ ವ್ಯಾಲ್ಯೂ ಈ ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಇದ್ರೆ, since all the three conditions are satisfied, you can say that given function f of x is continuous at that particular point and x equal to c is called x equal to c is called point of continuity. Point of continuity. x equal to c is called point of continuity. So these are the very important things. Three conditions are there. First condition, this should exist. Second, this should exist andre LHL is equal to RHL ಆಗಿರಬೇಕು. Third, limit value ಮತ್ತು function value ಎರಡು ಸೇಮ್ ಆಗಿರಬೇಕು. And x is called the point of very important continuity. Now let us start solving problems. Then you will understand better. Let us start 1 or 2 marks question problems first. Let us solve 1 or 2 marks also. Sometimes part A, part B will be asked, but always they ask 4 mark question in part. How to solve 4 marks question also I will tell you. Now to please, I have taken all the 3 conditions, very important conditions. Please mug up also. Please register in brain. That is very important. Now let us take the how to prove it is continuous. Your Rolle's theorem also, all polynomial functions are continuous. That is why whenever you write 2x plus 3, 2x square minus x plus 3 in Rolle's theorem, we used to say it is a polynomial of degree 2, polynomial of degree 1, it is continuous. All polynomial functions are continuous. Second one, all rational functions are, this is a rule actually, in continuous functions this is a rule, all rational functions are continuous. Polynomial function andre, you know, I told you f of x is equal to a naught x plus a1x1, see x a naught plus a1x plus a2x square, like this it goes on degree, that is polynomial function. Suppose here it is x to the power of 0 anta, degree of 0 it is. These are all called polynomial functions. All such functions are, say 2x plus 3, 2x square minus x, avella adu continuous. Here rational functions andre you must note px by qx, where qx is not 0. This is also continuous function. All rational functions are also continuous and polynomial functions also continuous. Now we shall take problems and solve. First we shall concentrate on 2 more problems. You have taken, I suppose you have taken? Yes. Kelbodu. Athwa prove that the function antanu kelbodu. Examine andre you have to write all the 3 conditions. Here also you should write all the. Prove that the function f of x is equal to 2x minus 3 is continuous at x equal to 2. It's a very simple problem. This question carries 2 marks. Prove that the function fx is equal to 2x minus 3 is continuous at x equal to 2. Now, see, I tell you 3 conditions you have to satisfy here. Eitherly less than or greater than illa, you need not worry about left hand limit, right hand limit question barala, because straight away limit exists at x equal to 2 ಅನ್ನೋದು ಮಾತ್ರ ನೋಡಬೇಕು ಅಷ್ಟೇ ಹೊರತು the left hand limit less x tending to 2 minus or x tending to 2 plus will not come. Okay, what is the first condition? First condition is whether this function at x equal to 2 is defined. Definitely x equal to 2, this function is defined. Now you write f of x is equal to 2x minus 3. Find out f of 2 continuous, because it is defined at x equal to 2 continuous antane x equal to 2, that is 2 into x kಡೆಗೆ 2 ಹಾಕೊಳ್ಳಿ minus 3, 4 minus 3, it is, call it as equation number. Again I am telling you f of x at x equal to c equal to 2, this is c actually. So x equal to c, find out f of x is 2x minus 3, f of 2 is 2 into 2 for minus 2. Now what you can say is f of x that is equal to 2x minus 3 is defined athwa exists, defined or exists, and it is equal to 1. Please note here f of x ತಗೊಳ್ಳಿ, f of 2 ಮಾಡಿ x ಕಡೆಗೆ 2 ಹಾಕೊಳ್ಳಿ, just simplify, you get 1 and say that f of x is equal to 2x minus 3 is defined at 1 ಅಥವಾ exists. You can also use the word exists. Defined ಅಂತ ಹೇಳ್ಬೋದು ಅಥವಾ exists 2x minus 3 defined at 1 or exists at x equal to 1 is defined at is defined that is equal to 1 defined at it is defined at please change the thing, defined at x equal to 1 that is defined at x equal to 2 because this is the continuity point. F of x 2x minus 3 is defined, please change it, okay, make a correction, is defined at x equal to 2 and f of 2 is f of 2 we are defined at 2, f of 2 is 1. Again I will explain. F of x is equal to 2x minus 3, f of 2 ತಗೊಳ್ಳಿ, it is defined 2 ಹಾಕಿದ್ರೆ 1 ಬಂತು. So f of x 2x plus 3 defined at x equal to 2 and its value is 1. Now we shall go for second condition. I told you second condition alli limit extending to c of f of x check ಮಾಡಬೇಕು. ಅದರಲ್ಲಿ ನಾವು ಏನು ಮಾಡಬೇಕು, we need not go for, as I said, less than greater than ಇಲ್ಲ ಇಲ್ಲಿ, we need not go for left hand limit, right hand limit. That is understood that both exist and the limit value is there. Okay, in such type of problem. So you take the second condition, calculate limit extending to 2 of f of x or limit extending to 2 of 2x minus 3. Sorry, limit extending to 2 of, you know how to calculate the limits. It is put x equal to 2 here. 2 into 2 minus 3, 4 minus 3, that is also 1. Call it as equation number 2. So limit value is also 1, f of x is this also 1. Therefore, third condition is limit extending to that much is equal to f of x at this, both are same idre, limit that the function is a continuous function. From 1 and 2 you can say, from 1 and 2 ಬೇಕಾದ್ರೆ ಬರಿಬೋದು, ಇದರ ಆಗಿನೂ ಬರಿಬೋದು, it is observed ಅಂತ ಬರಿಬೋದು. From 1 and 2 limit extending to 2 of extending to 2 of f of x is equal to f of x at x equal to 2 is equal to 1. That is also 1, this is also 1. Very important thing is this. Limit extending to c of f of x should be equal to, you see my third condition, f of x at x equal to c, both are 1. Then now this is 1. Since all the three conditions satisfied, this is how you have to present the answer. Satisfied, the given function is continuous function. The given function is continuous at x equal to 2, and you should also write continuous at x equal to 2, and x equal to 2 is the point of continuity. What you should write? X is equal to 2 is the point of continuity. This was the problem. ಎರಡು ಮಾರ್ಕ್ ಕ್ವಶನ್ ಕೇಳಬಹುದು. What are the things you should take? F of x at 2x minus 3 at x equal to 2 ಇದೆ ನೋಡಿ. Find f of x, f of 2 ಕಂಡುಹಿಡಿಕೊಳ್ಳಿ. It is defined. ಒಂದು ವ್ಯಾಲ್ಯೂ ಬಂತು. That is real number. That is at x equal to 2 is 1. Similarly, calculate limit of that. Okay. When you calculate the limit of this, you got that is also 1. You need not go for left hand limit or right hand limit because it is no less than or greater than, nothing is given. Don't worry about left hand. Straight away go for limit calculation. No question of 2 minus 2 plus. I will show you where we have to apply that. Now that is also 1. Third condition, this limit is equal to that function defined at f into 2 is both are same 1. Therefore, all the conditions satisfied. The given function is continuous at x equal to 2 and x equal to 2 is the point of continuity. This is how you should discuss the point of continuity. We shall take next problem. Continuity for the function. Examine ಅಂತ ಕೊಡಬಹುದು ಅಥವಾ ಡಿಸ್ಕಸ್ ಅಂತ both are same, all the same. ಡಿಸ್ಕಸ್ ಅಂತ ಕೊಡಬಹುದು, ಎಕ್ಸಾಮಿನ್ ಅಥವಾ ವೆರಿಫೈ ಅಂತ ಕೊಡಬಹುದು, ಅಥವಾ prove that ಅಂತಾನು ಕೊಡಬಹುದು. All because see polynomial function is a polynomial function because this degree is 1. All polynomial functions I am telling you are continuous functions. That is why we take that and write it in Rolle's theorem also. Understood? Examine the continuity of fx is equal to x square minus x 2x plus 3 at x equal to 2. At x equal to 2 ಮಾಡಿದಲ್ಲ at x equal to 3. Examine the continuity of the function f of x is equal to x square minus 2x plus 3 at x equal to 3. Now take the same thing. ನೋಡಿ again take the same thing. F of x is equal to ಇಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ. Now f of x at this is given. Now calculate f of 3 calculate ಮಾಡಿ. F of x is f of x is equal to x square minus 2x plus 3. Calculate f of 3 one. F of 3 calculation money. It is defined wherever x equal to 3. It is 9 minus 6 plus 3, 12 minus 6 or it is 6 calculation. Understood? F of x ಕೊಟ್ಟಿದ್ದಾನೆ f of 3 ಕಂಡುಹಿಡಿಕೊಳ್ಳಿ. It is defined f of 3 value is given. So f of x is equal to I am replacing this. Please take down. Don't write in your book like this, sir. Right? Do it. Redo it. F of x is equal to x square minus 2x plus 3 is defined at x equal to 3 and f of 3 is how much? 6. F of 3 is equal to 6. Understood? F of x ತಗೊಳ್ಳಿ, f of x ತಗೊಂಡು f of 3 ತಗೊಳ್ಳಿ. Now you are doing this. Calculate ಮಾಡಿದ್ರೆ 6 f of 3 defined and it is equal to 6. Now you take limit extending. Now you should go for second condition. Limit extending to 3 of f of x. Because this is the point of continuity he is telling at 3 ತಗೋಬೇಕು. Now limit extending to 3 of f of x ಏನದು? Limit extending to 3 of f of x. F of x is x square minus 2x plus 3 ತಗೊಳ್ಳಿ. Now the x ನ ಕಡೆಗೆ 3 ಹಾಕಿದ್ರೆ ಅರ್ಥ you have calculated how to calculate limits you know and you have calculated also. So 3 square minus 2 into 3 whatever is there the same thing you will get 9 minus 6 plus 3 or it is also 6. So you got limit also extending to 3 of this much is 6. Conclusion what you should write from 1 and 2 if you want you can say 2 you can write from 1 and 2 you can say limit extending to 3 of f of x is equal to f of x at x equal to 3 is equal to what you should write? Is equal to 6. You should write 6 because you have calculated f of x at x equal to 3 is also 6 and this is also 6 you should write 6. Since all three conditions are satisfied, please take down. Since all three conditions are satisfied, the given function is continuous at x equal to 2 Allah at x equal to 3 1. At x equal to 3 and x equal to 3 is called the point of continuity. This much you should do for 2 mark question. They may ask 2 mark question also of such type. Then you have to mention present all these things. You take one more problem and then you will go for a different type of problem where you have to take left hand limit, where you have to take right hand limit also. Okay, limit ತಗೊಳ್ಳಿ ಅವೆರಡು ಸೇಮ್ ಇದೆಯಾ ನೋಡಿ then you write it is continuous function. Okay, now we should examine the continuity of the function. Take down f of x is equal to 1 minus 5x at x equal to minus 2. Examine the continuity of the function f of x. See here also it is polynomial because degree it is 1. All polynomial functions are continuous functions. All rational functions are also continuous functions. These are the things you should know. Now, examine the continuity of the function f of x equal to so much at x equal to minus 2. Now you take here. It is at x equal to minus 2, it is defined. Function is given. You have to calculate f of minus 2. Now you take this first condition. We have to prove f of x is equal to 1 minus 5x. F of minus 2 tawali. Take down f of minus 2. Take at minus 2, 1 minus 5 into minus 2, 1 plus 10, it is 11. So, f of x is equal to 1 minus 5x is defined. Defined and exists and at x equal to minus 2. That is, f of minus 2 is 11. Understood again? All these things understood. F of x tagoli, x ಗೆ minus 2 ಹಾಕೊಳ್ಳಿ, then it is 11, and f of x equal to 1 minus is defined at x equal to minus 2, f of minus 2 is 11. Now we have to calculate limit. ಎರಡನೇ condition ಗೆ ಬಂದಿ, this is first condition, satisfied. Second condition is you go limit extending to minus 2 of f of x, or limit extending to minus 2, minus 2 of f of x is 1 minus 5x, or you can say that 1 minus 5 into minus 2, x at minus 2 actually, 1 plus 10, 5 into 10, 11, that is 1 plus 10 is 11, call it as equation number 2. This also 11, limit extending to that also you got 11, and this one also you got 11. You can say from 1 end to, you can always write from 1 end to limit extending to minus 2 of f of x is equal to f of x at x equal to minus 2 is equal to, both are equal to 11. Understood? You should, idondu bandubittidre, you can say that limit ondu matte function ondu bandubittidre, you can say that the third condition failed, because that is not equal to this. You can straight away say, will solve some problems of that type also, you will understand. Now you say that it is all the conditions are satisfied, f of x is continuous at x equal to minus 2, and x equal to minus 2 is change it. Don't change into the original problem, definitely right. X equal to minus 2 is the point of continuity. I hope all of you have understood, because this aspect you should remember very well. Your engineering classes also, it starts from continuous functions again. Your higher classes also, so you should have a strong background of continuous functions. Yes. Now, I will give you some 2 problems, try in your house. First problem is, discuss the continuity of the function f of x is equal to x square minus x minus 3 at x equal to 4. First one, f of x is equal to x square minus x minus 3 at x equal to 4. Second one, you can take f of x is equal to 4x minus 3 at x equal to 0. So these are the 2 problems you can check, do it, practice well, examine the continuity of the function f of x equal to x square minus x minus 3 at x equal to 4, and f of x 4x minus 3 at x equal to 0. So you have to examine the, first find out the function defined, afterwards limit, check whether it is same, then you will get the answer. Okay. Now we shall do with suppose, if the point is not given, they say all real numbers, then how to calculate, how to prove that it is a continuous function. Take the problem, prove that the function fx equal to 4x plus 3 is continuous on all real numbers. Is continuous antane bittu bidabodu, athava on all real numbers. is the question. Suppose here is the difference. So what is the difference between this problem and the previous problem? Here it is, they are asking you to prove the continuity of the function, of this function, on all real numbers in the perpetuum, and they have not given the value like this, x equal to 4 or x equal to 0 agilla. Very real number ಕೊಟ್ಟರು. ಇಂಥ ಪ್ರಾಬ್ಲಮ್ಸ್ ನಲ್ಲಿ ಇದು 1 ಮಾರ್ಕ್ ಕ್ವೆಶ್ಚನ್ ಕೊಡಬಹುದು ಎಕ್ಸಾಮಿನೇಷನ್ ಅಲ್ಲಿ, ಇಂಥ 1 ಮಾರ್ಕ್ 2 ಮಾರ್ಕ್ ಕೊಡಬಹುದು ಇಂಥ ಸಿಚುಯೇಷನ್ ಅಲ್ಲಿ. But in this circumstances, take some x equal to c, because we are all calculating at x equal to c only. But here c is known, but here c is not known. So let x equal to c belongs to that real number. First thing is you should write let x equal to c, that particular c belonging to R. Now f of x equal to 4x plus 3 at x equal to c is defined, because you are taking that real number, no, but the perfect real number, you can take c at x equal to c is defined. So f of c is 4c plus 3, x in 3. That's all. In all the cases where x is not mentioned, the point of continuity, you have to take let x equal to c belonging to some real number and other calculate. But this is first condition. Next condition is limit extending to c of f of x, because c is the real number. No question of left hand limit, right hand limit, because there is no less than or greater than. Now you see limit extending to c of f of x, and it is limit extending to c of f of x is 4x plus 3, or it is limit x equal to c happy, this is nothing but 4c plus 3. This is 1, no? 2. From 1 and 2, this limit is equal to that function. Therefore, it is continuous. Finish. Only just 2 lines. Now, what you should write? Since limit extending to c of f of x is equal to f of x at x equal to c is equal to both are 4c plus 3. Since all the conditions are satisfied, the given function fx is continuous on all real numbers. That's very, very simple. On all is continuous on all real numbers. Here you should know, when a point is not given, the point of continuity take S as c, take it as c belonging to R, find out f of x at x equal to c, limit c togoli f of x togoli, calculate, and this will be okay, same thing, so continuous, because this and this are same, and it is continuous on all real numbers. That's all what you have to write. Shall we go to, you understood this? Shall we go to the next problem? Take the problem, next problem. Prove that the function fx is equal to 1 by 5x minus 1 where x is not equal to 1 by 5, where x is not equal to 1 by 5 is a continuous function. On all real numbers are understood. Sometimes they may give on all real numbers and the sometimes they may not give. It is understood that it is continuous function on all even if they don't give also you should. Here one condition is there, you should watch. X is not equal to 1 by 5. Suppose x equal to 1 by 5 ಆಗಿಬಿಟ್ರೆ 5 into 1 by 5, 1 minus 1, 0, 1 by 0 infinity. function itself is not defined. That is why they have given this condition. If they don't give this condition, what is to be done, I will tell you. Anyway, but problems, what is the condition? No? X is not equal to 1 by pi. Again I told you, let C, you take C belongs to R. F of x is 1 over 5x minus 1. F of C tagoli 1 over 5c minus 1 as equation 1. Okay. Now f of x at C is equal to 1 at C f of x at x equal to C defined and it is equal to 1 over 5c minus 1. F of x at x equal to C is defined and it is 5c minus 1. Now first condition satisfied. Second condition, this exists sometime. Limit extending to C of f of x. Limit extending to C of f of x. Limit extending to C of f of x given by 3. You write that 1 over 5x minus 1. X is equal to C happily 5c minus. From 1 and 2, see this and this are same. From third condition, this is from 1 and 2, limit extending to C of 1 over 5x minus 1 is equal to limit f of x at x equal to C is equal to 1 over 5c minus 1. Changing. Third condition is this limit should be equal to that function. This should exist, this should, all the three conditions are, since all three conditions are satisfied, since all the three conditions satisfied, the given function fx is continuous on all R. Except x is not equal to again please understand how we have done. Okay, how to do such thing. When point of continuity ಕೊಟ್ಟಿದ್ದರೆ, how to calculate the continuous function. C at the tagoli, let x equal to C belonging to R at the tagoli, calculate and check. Some 2-3 problems I tell you. Prove that first one, fx is continuous. Please take down. Focus Manipa. F of x is continuous. F of x is equal to x square plus x minus 1 is continuous on R. Second one, f of x is equal to 1 over x minus 3 except x is not equal to 3. X is not equal to 3 is continuous on. So illi x equal to C ತಗೋಬೇಕು, C belonging to R ಅಂತ ತಗೋಬೇಕು. Then you have to calculate f of C, limit extending to C of f of x, both the cases, but you should not consider x is not equal to. Okay. Now one more question they may ask like this also. Continuity of the function, find the discontinuity of the function fx is equal to, find the discontinuity of the function fx is equal to 1 over 7 minus x when x belongs to R. Yes, now it is very easy. I think you yourself can tell me for what point it is discontinuous. See here, if you take f of x equal to 7 1 minus x, f of c 7 minus c 1 over 7 minus c, then limit also will get it is continuous. But for one particular point, it is discontinuous function. How to say that at what point it is c? If you put x equal to 7, 1 over 7 minus 7, 1 over 0, that means that itself is not defined. The function itself is not defined. Now, how to do this problem? Consider like this. If they ask f of x is equal to 1 over 7 minus x. Suppose let x equal to 7 belonging to R. ಯಾರು ತಗೋಬೇಕು 7 ಅಂದ್ರೆ you should equal to 0. ಬೇಕಾದ್ರೆ ಅದು ಗೊತ್ತಾಗದೇ ನೋಡ್ಕೊಳ್ಳಿ. 7 minus x equal to 0 or 7 equal to x. This is how you should get the value. X equal to 7 belonging to R you take. Then f of 7 is 1 by 7 minus 7 1 by 0 infinity not defined. ಇದೇ ತರ ಬರೀಬೇಕು. Please note that you have to write like this. 1 by 7 minus 0 1 by 0 infinity not defined. That means f of x is okay is not continuous at x equal to 7. That means f of x not defined. You should write f of x not defined. Therefore, x equal to 7 is the point of discontinuity. We should say that it is the point of x equal to 7 is the point of discontinuity. Very important. See here, we should take x equal to, how to get the 7 ಅಂದ್ರೆ ಆ 7 ಏನು ಇರುತ್ತೆ ಅದನ್ನು equal to 0 ಮಾಡಿ you will get the value of that. Suppose you take x equal to 7 ಮಾಡಿದ್ರೆ it is not defined because 1 by 0 infinity ಬಂದ್ಬಿಡ್ತು. It is not defined continuous at x equal to 7. This is the point of discontinuity. Then if they ask whether all other points continuous, definitely you take 2 1 over 7 by 5 3 1 over 4. All these things are defined because it is a rational function. I told you all rational functions are continuous except for x equal to 7. But here what they have asked, find the point of discontinuity ಅಂತ ಮಾತ್ರ ಕೇಳ್ತಾರೆ. You should write that the point of discontinuity is x equal to 7. Understood? Suppose if the same problem is given, take this problem. Find the point of discontinuity of the function fx is equal to, suppose if they ask like this, 1 over 2x minus 3. Of course x belonging to R. What is the point of discontinuity? I told you, just to take this 2x minus 3 equal to 0 ಮಾಡಿದ್ರೆ 2x equal to 3 x equal to 3 by 2. Suppose 3 by 2 ಹಾಕಿದ್ರೆ 2 cancel 3 minus 3 1 by 0 it is not defined. So now you say how to get x ಗೊತ್ತಾಯ್ತಲ್ಲ, f of x is equal to 1 over 2x minus 3 and f of 3 by 2 is nothing but 1 over 2 into 3 by 2 minus 3 1 over 3 minus 3 1 over 0 infinity not defined. Since f of 3 by 2 is not defined, f of x at x equal to 3 by 2 is discontinuous function. It is discontinuous function. Therefore, x equal to 3 by 2 is a point of discontinuity. You should say that it is a point of not continuity, discontinuity. For all other points, it is continuous. So these are the things you should check. And also take one more problem, that find the point of discontinuity. One more problem for continuity for fx is equal to 1 over 7x minus 1. 7x minus 1, x belonging to a percentage. So please find out this, where it is, for which point it is discontinuous. That's 1 mark. 1 by 7 is the point of discontinuity. ಅಷ್ಟೇ ಮಾಡಿದ್ರೆ ಸಾಕು. X is 3 by 2 is a point of discontinuity. ಇದನ್ನು ತೋರಿಸ್ಬಿಟ್ಟು ಮಾಡಿಬಿಟ್ರೆ you will get 1 mark. ಅಥವಾ find the point of discontinuity is x equal to 1 by 7 ಅಂತ ಬರೆದುಬಿಟ್ರು ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ. ಅದೆಲ್ಲ ಬರೀದೇ ಇದ್ರು ಕೊಡ್ತಾರೆ. But examine the discontinuity ಅಂತ ಹೇಳಿದ್ರೆ you have to write all these things. It is necessary. Now let us take some problems. I tell you, let us take some problems. 1 or 2 ಮಾಡೋಣ, ಆದರೆ ಟೈಮ್ ಸಿಕ್ಕಿದ್ರೆ ಈಗ. And next, in my next class, we will take up lot of problems of 4-mark question. Okay. Now we should do 1 or 2 problems if time permits. Okay. I hope all of you are following it. Fx. Examine the continuity of the function. Fx is equal to x plus 2 if x less than or equal to 1 and x minus 2 if x greater than 1. Fx, very important problem for examination. You may get it also. This such type of problem carry 4 marks. Examine the continuity of the function. Fx is equal to x plus 2, comma, if x less than or equal to 1, x minus 2, x less than, greater than 1. ಆಮೇಲೆ ಅವರಿಗೆ ಒಂದು ಸ್ವಲ್ಪ ಬಿಸಿನೀರು ಅದು ಮುಗಿಯೋದಕ್ಕೆ ಕ್ಲಾಸ್. And the continuity of the function fx, x plus 2 if x less than or equal to 1 and x minus 2. See here, ನೀವು 3 conditions prove ಮಾಡಿ, all the 3 conditions prove ಮಾಡಿ, you have to do that. It's a very important problem where all the 3 conditions. Why ಅಂತ ಹೇಳ್ತೀನಿ ನೋಡಿ. Less than or greater than ಕೊಟ್ಟರೆ you have to apply LHL or HL. Very important thing is when less than greater than ಕೊಟ್ಟರೆ always you should apply left hand limit and right hand limit also. Left hand limit to right hand limit to ಎರಡು ಮಾಡಬೇಕು. ಈಗ ನೋಡಿ x equal to 1 function is defined, ಇದು ತಗೊಳ್ಳಿ. x equal to 1 ಅನ್ನುವಾಗ equal to ಅಂತ ಎಲ್ಲಿ ಬಂದಿರುತ್ತೋ ಆ ಫಂಕ್ಷನ್ ತಗೋಬೇಕು. Whether it is defined, first condition that yes, at x equal to 1 it is defined, x plus 2 f of 1 ಕಂಡುಹಿಡ್ಕೊಳ್ಳಿ, all test. Then we should go for condition 2, left hand limit ತಗೋಬೇಕು, right hand limit ತಗೋಬೇಕು. Left hand limit ತಗೊಳ್ಳುವಾಗ left less than ಅಂತ ಇರುತ್ತಲ್ಲ, always please note down. Left than ಅಂದ್ರೆ left hand limit, greater than ಅಂದ್ರೆ right hand limit. Please note this. Less than ಅಂದ್ರೆ left hand limit, right greater than ಅಂದ್ರೆ right hand limit. Please note this 2 things. Now we shall take f of x2 is equal to so much, left hand limit, right hand limit ಇದೆ. Now equal to ಅಂದ್ರೆ that function ಇದು ತಗೋಬಾರ್ದು. You should take equal to ಅಂತ ಇರುತ್ತೆ, ಅದು ತಗೊಳ್ಳಿ. First condition, f of x at x equal to 1 is defined and that is x plus 2. At x equal to 1 equals ಅಂತ ಇರುತ್ತೆ, ಅದು ತಗೊಳ್ಳಿ. X equal to 1 x plus 2 defined. So f of x is your x plus 2. So f of 1 ತಗೊಳ್ಳಿ, f of x is equal to x plus 2 ತಗೊಳ್ಳಿ. Now equal to 1 is defined and it is x plus 2. f of 1 is equal to ಅಂತ ತಗೊಳ್ಳಿ ಅಂತ ಹೇಳಿದೆ ನಾನು. And f of 1 ತಗೊಳ್ಳಿ, f of x plus is x plus 2, f of 1 ತಗೊಳ್ಳಿ, 1 ತಗೊಂಡ್ರೆ it is substitute ಮಾಡಿ 1 plus 2 it is f of 1 is keep it as it is. Understood? Defined ಅಂತ ಯಾವುದು ಇದೆಯಲ್ಲ ಇದು ತಗೊಂಡು you should take this and f of x equal to 1, f of 1 is defined and it is 3. Now let us calculate. You should not calculate straight away limit. I told you less than ಮತ್ತೆ greater than ಎರಡು ಕೊಟ್ಟಿರುವಾಗ, less than greater than ಕೊಟ್ಟಿರುವಾಗ you have to calculate left hand limit and right hand limit. So now you take LHL, left hand limit ತಗೊಳ್ಳಿ, left hand limit is your LHL, left hand limit extending to 1 minus ಅಂತ ಬರ್ಕೋಬೇಕು. Left hand limit ನಲ್ಲಿ 1 minus ಅಂತ ಬರೆದಿದ ತಕ್ಷಣ you should consider this, not this. Less than is left hand limit always. Extending to 1 minus ಅಂತ ತಗೊಂಡಾಗ x plus 2 ತಗೊಳ್ಳಿ. ಅಲ್ಲಿ minus 1 ಹಾಕಬೇಕಾಗಿಲ್ಲ, 1 ಹಾಕೋದು. 1 plus 2 it is 3. And left hand limit. Left hand limit to right hand limit ಎರಡೂ ಒಂದೇ ಇದ್ರೆ limit exists ಅಂತ. Now you take right hand limit. Let us check. Right hand limit is limit extending to 1 plus ಅಂತ ಬರೀಬೇಕು. ಆವಾಗ ಯಾವ ಫಂಕ್ಷನ್ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಂದ್ರೆ greater than 1 is always RHL. You should take x minus 2. Now it is 1 minus 2, it is minus 1. ನೋಡಿ ಇದು ಬೇರೆ ಇದು ಬೇರೆ, ಇದು 3 ಇದು minus 1. You write that from 1 into LHL is not equal to RHL. That means left hand limit is not equal to right hand limit. Left hand limit ಬಂದ್ಬಿಟ್ಟು 3 ಬಂತು, right hand limit minus 1 ಬಂತು. Therefore what is your conclusion? Limit extending to ಇಲ್ಲಿ ಏನು ಇವಾಗ 1 minus 1 plus ಏನು ಇಲ್ಲ, f of x does not exist. You should say that it does not exist. Limit extending to 1 of f of x does not exist. Therefore second condition fail ಆಯಿತು. Second condition failed. ಈಗ ಅದು ಆಗಿದ್ರೆ ಅದನ್ನು ಅಷ್ಟೇ ಬಂದಿದ್ರೆ ಇದು ಒಂದು minus 1 ಬಂದಿದ್ರೆ this exists and minus 1, ಆಮೇಲೆ you should go for third condition. ಇದು ಚೆಕ್ ಮಾಡಬೇಕು. Second condition failed. Therefore you should write that the given function is discontinuous. ಏನಂತ ಯೂಸ್ ಮಾಡಬಹುದು? You can use the word discontinuous ಅಂದ್ರೆ not continuous at x equal to what? At x equal to 1. Therefore x equal to 1 is the point of discontinuity. X equal to 1 is the point of discontinuity. ಇಷ್ಟು ಬರೆದರೆ, ಇಷ್ಟು ಮಾಡಿದರೆ you will get 4 marks. You will get 4 marks for this problem. So examine the continuity of the function f of x equal to so much. ಈ ಪ್ರಾಬ್ಲಮ್ಸ್ ನಲ್ಲಿ ಇವೆಲ್ಲ ಕಂಡೀಷನ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಬೇಕು. ಅದರಲ್ಲಿ ಡೈರೆಕ್ಟ್ LHL RHL ಎಲ್ಲ ಇದಕ್ಕೆ ಬೇಕು. ಫಸ್ಟ್ f of x at x equal to 1 ಡಿಫೈನ್ ಮಾಡಿ, ಎಲ್ಲಿ ಈಕ್ವಲ್ ಟು ಅಂತ ಇರುತ್ತಲ್ಲ ಆ ಫಂಕ್ಷನ್ ತಗೊಳ್ಳಿ, f of 1 ಹಾಕೊಳ್ಳಿ. Now second condition, because it is less greater ಎಲ್ಲ ಕೊಟ್ಟಿರೋದ್ರಿಂದ your limit should exist. That is your left hand limit should be equal to your right hand limit. So limit ತಗೋತೀರಿ, extending to 1 minus ಅಂತ ತಗೋಬೇಕು. 1 minus ಅಂದರೆ less than 1 ಇರೋ ಫಂಕ್ಷನ್ ತಗೊಳ್ಳಿ. minus 1 ಹಾಕಬಾರ್ದು, 1 ಹಾಕಬೇಕು. It is 3. Right hand limit you take, limit extending to 1 plus ಅಂತ ತಗೊಳ್ಳಿ. 1 plus ಅಂತ ತಗೊಂಡ್ರೆ x minus 2 ತಗೊಳ್ಳಿ. 1 minus 2 minus 1. ನೋಡಿ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಎರಡು ಸಮ ಇಲ್ಲ. ಸಮ ಇದ್ದರೆ then you should write limit extending to 1 of f of x exists. But ಇಲ್ಲಿ they are different. Therefore LHL is not equal to RHL. Limit fx extending to 1 does not exist. Second condition failed. Given function is discontinuous at x equal to 1. At x equal to 1 is the point of discontinuity. I think this we shall end with this, and in my next class I give some problems, because we have to do a lot of problems on this particular thing, because one 4-mark question will be asked. Now what we have solved is 2-mark question, 1-mark question, and this 4-mark question we have to solve it. Some more lot of problems are there. We shall take up in my next classes. Okay. Thank you.